Okay, good evening. This is week 8 of P03. Now, the agenda for today, we're going to look at heat treatment. So I'm not going to talk about all heat treatment process. I'm just going to, I pick a few that you commonly use, which is full annealing, normalizing, process annealing, spheroidization, stress relief anneal. Okay, download this figure on Avenue to Learn. Okay, we'll be drawing stuff on this figure quite a bit. Okay, what else to say? Okay, whatever I teach from today, from week 8 until the end, I will test you in your final exam. Okay, I will not test you what I have asked you on in the midterm. Okay, but there are things that you still have to remember, like Johnson co-equation, what certain term means. Okay, because I'll be still referring to them in this from here on. Okay, so let's look at heat treatment. Okay, let's look at heat treatment. Okay, so let's look at heat treatment. Okay, heat treatment is a process of controlling heating. I know this is obvious, but and also, okay, and cooling. Okay, and cooling to change the microstructure okay, and also mechanical properties. I always have the perception, okay, that when the term used on heat treatment, I only focus on what? Heating, right? That's not true. Okay, heat treatment is basically controlling both heating and also what? Cooling. Okay, and usually 99% of the cases okay, is after heat treatment. Okay, after heat treatment, the change in shape and dimension, okay, and dimension should be minimized. As I say, 95% of the cases. Okay, 95% of the cases, you want your heat treatment. After your heat treatment, you want a change in shape, dimension to be minimized. Okay, there's 5% of the cases that you want it to change the shape and you also want it to change the dimension. Can anyone think of any, please? Anyone? That after heat treatment, you after or during the heat treatment, okay, you deliberately, I mention again, you deliberately want a change in shape and dimension. Can anyone think of any, please?
Is it for fits?
fits.
Assembly?
Assembly. It can be sometimes if it is interference feeds. Yes. Okay. What is one very obvious case? Anyone else?
Forging.
Of?
Forging of steel to like make a sword or something.
Yeah, there you
Or
go.
a knife.
Okay, change in shape and dimension is desire. Example. Samurai sword. Okay. So have you seen a samurai sword before? So a samurai sword is one of the sharpest sword around. Okay. So what they do is when they were forging or then they were forging the sword or processing the sword. Okay, so this is the handle. The sword is straight. Okay, my drawing is not fantastic. Okay, so what they do is when they quench in water. So if this is water, wait, I'm all of a sudden I don't think they use water. I think they use brine. Okay, brine is a salt water. Okay, so we know that if the sword if this is a sword, right? If the quenching is straight down, right? Straight down, right? The change in shape will be minimum, yes or no? So what they do is they quench the sword in such a way that the starting initial position is like this. Okay, so this is the starting initial position of the sword. And they don't quench it down this way, okay? It has to have a certain curvature motion. They have to have a certain curvature motion. Okay. So at the end of the day, what happened is the sword is no more straight. Okay, the sword is bent in a certain shape. Okay, so if I'm not wrong, a samurai sword is not straight. It has a certain curvature. Okay, so this is the curvature. So this is one application that you see that you want the change in shape and geometry. Okay, so one application. But usually, okay, if you are manufacturing products, okay, you want to minimize, okay, the change in shape, and this is just one case that you don't mind the change in shape and also the change in geometry. Okay, so note the higher. Okay, so when we do heat treatment, the higher the holding temperature, okay, the higher the holding temperature before quenching. Okay, before you quench, the greater the possibility the greater the possibility in change of dimension. Shape. Okay. And the last one is really bad crack formation. Okay. So if you have crack, okay, you're in a bit of a trouble. Okay, so you don't want any cracks to happen at all. Okay, especially when you do quenching. Okay, if you quench, you got a crack, it's bad news. Usually you have to sacrifice the entire part, or the entire part cannot be used. So an important thing to look at is phase diagram. As the one you see down here, okay, as you can download on Avenue to Learn, are usually used to predict the resulting microstructure. Okay, so you can see lines. You can see this line over here. You can see the ferrite rod line. Okay, remember your term test. I give you two equations. So one equation represents this line over here. The other equation represents that line over there. Okay, right. So I'm going to draw a lot on this diagram over here as I explain each heat treatment process. Okay, any questions so far? Okay, no, I don't hear anything. So the first one we are going to look at, what we call is full annealing. As I said, I did not know that this was important. Heat treatment, how important it is, until I was doing the 3 case study. Remember, I told you about those case study that I've done before the term test, right? Ooze ball, dual phase steel, trip steel, how critical is heat treatment, okay? So let's look at full annealing first. Okay, now when I teach heat treatment, it's not just, okay, guys, this is full annealing. It spells F-U-L-L-A-N. No, it's not like that. I'll tell you when to use it and why. Not necessarily the full why, but when to use it and what is its limitation. So if you want to carry out full annealing, okay, if you carry out full annealing. So if you look at this is our eutectoid carbon, right? So this is where we my lines are not straight, but you see this is 0.8. Yes or no? Okay. Sometimes you see 0.8, sometimes you see 0.73, sometimes you see 0.83. It's okay, it's all about the same. So what temperature range should you heat to correct to conduct full annealing? Okay, so I'm going to draw the operating boundary. So the operating boundary, so bear with me, okay? So it's about here. So after you pass the eutectoid carbon at 0.8 or 0.83, okay, to carry out full annealing, okay, you just need your temperature to be held this way. Okay, so this region over here, this region you see over here, is what we call the region for full annealing. Okay, that is